Welcome back. So we've got now our process. And I want to come back to this and really harp on something very important. After you've got your hypothesis tested, after you've got your significance level decided, after you've got your sample data, after you've found your test statistic or you've used your technology, after you've found your p-value, here is how it all comes down. If your p-value is smaller than your significance level, you can and probably should reject the null hypothesis, whatever it was. If, on the other hand, it's greater than or equal to A, you can't. You fail to reject. That is what you do. That is the conclusion you reach. Now, the problem with that is random data is going to random, right? You're going to have random data in there. And so maybe it is the case that you've got a random sample, and based on your random sample, it should be one way, but it's so far out, it looks like the other. Maybe you've got that really rare outcome. Maybe it happens. And that's going to be a problem. So the last thing to talk about, and I started that in the last video, let me come back and really hit it again. You've got errors whenever you do anything. And doing nothing is doing something in this class. Right? In statistics, if your alpha value is too generous, if it's a very high alpha value, that means that we're going to start rejecting a lot of stuff. There we go, right? A high, hang on, what is this? If the p-value exceeds A. So if alpha is high, if alpha is a really big number, you're going to start rejecting a lot of stuff. And that can be a problem, right? If you're rejecting a lot of stuff because alpha is really big, you're in trouble. Conversely, if you set alpha to be really low, you're in trouble again. Because now, if you set alpha to be really low, yeah, you're just not throwing out false null hypotheses. On the other hand, if you set it too high, you'll start accepting stuff you shouldn't. So whenever you're doing hypothesis testing, it's going to get you one way or the other, usually both. There are two types of error in hypothesis testing. You've got error whenever you make alpha too strict, which is too low, I believe. That creates false positives because you start rejecting stuff that you shouldn't actually reject. On the other hand, if you are setting it to be too very, whatever the other number is, if it's a very small alpha value, then P is going to be over it. So if alpha is really, really small, then you're going to start having false negatives. And that's where you start rejecting the null hypothesis. Or you should reject the null hypothesis, but the test is like, yeah, it's okay. And I've done way too many videos today. I'm starting to lose my mind. But basically, the issue is if you are trying to eliminate one sort of error, you will get more of the other. So if you take, say, alpha to be 0, that means, yeah, you'll never have a type 1 error. You'll never have a false positive. But it also means you'll have no positives at all because you're going to reject everything. On the other, I'm sorry, you're not going to reject everything, right? Positive means rejection. And I think that's getting me confused. Also, I've been doing this for like 12 hours today. But anyway, that's one issue. So you have to decide on the best value for alpha that gives you the least of both errors, or an acceptable amount of one error and an acceptable amount of the other error. 0.05 has the lowest combined error, so that's the go-to. But depending on your situation, you might want no type 1 error or no type 2 error, and you can do that. And finally, just to wrap this up, we failed to reject our sleepwalking one because alpha was 0.05, our p-value was 0.193, so we failed to reject. There isn't enough evidence to show that 30% was wrong. And finally, always make your hypothesis independent of your data. Always pick alpha before you do any work. Always recognize that just because you fail to reject doesn't mean it's true. It just means you failed to reject. And we got errors.